So hello everyone, today we'll be understanding a very interesting state idea of dynamic programming, which is, uh, well, I call it two-pointer DP. So it's two-pointer DP. What's the basic idea? Whenever you're given two sequences, let's say S and T, whenever you're given two sequences, okay, and the relation is something like this. A question is all about matching these sequences. And when do you apply DP, right? When do you apply DP? When you need to explore all possibilities. When you need to explore all possibilities you apply basically you apply recursion, right? You apply recursion, which you can optimize to DP. All right. So let us understand these kind of problems where you need to generate a match between two sequences. How do you match two sequences? So using this technique, you can solve many problems, but the popular ones, like the classic ones, are LCS problem, which is nothing but longest common subsequence, and you can also solve this edit distance problem. Edit distance problem. All right. So today we'll be talking about these two problems using the same technique. So let us understand the technique first using a problem. Let's take a problem. Uh, so let's take longest common subsequence. All right. So what does this problem say? Given two strings text1 and text2, return the length of their longest common subsequence. If there's no common subsequence, return 0. A subsequence of a string, okay, we know what's a subsequence. So you'll be given two strings. You need to find the longest common subsequence. That means the query is related to matching. All right. The query is related to matching these strings. And one more thing, one more very important thing. Whenever you're finding longest common subsequence, is there any other way except trying all the subsequences, like keeping one character, removing one character, keeping one character, removing one character, and you need to try all these possibilities, right? Is there any other better way? Like, is there a greedy way? Like, you can guarantee this would be the right answer for this? Actually, no, there's no other way, because you don't know if you take a particular character, would it contribute to the subsequence you're searching for? You don't know. So uh, the only way you can solve this is by exploring all the possibilities, that is brute forcing or recursion. So let us understand how recursion works for this, or else how the brute force works for this, perhaps. So we'll be having this string A, B, C, D, E, and A, C, E, and like, yeah. So this is of size n, this is of size m. Compare the last mth character of this string and nth character of this string. Do they match? Yes. That means there's a subsequence that has a match. There's this subsequence. So currently the length of my longest common subsequence would be 1 plus. Now, whatever the function I applied here, let's say I applied a function name phi here. Let's say I applied a function phi of s comma t here, which gave me this particular length. Okay, till here, phi of s comma t gave me the length. Now I need to apply this phi of s comma t for these two strings, right? So phi of s 0 to n minus 1, t 0 to m minus 1. I'll be applying for these strings now. So, okay, these two things are not a match. Okay, D and C don't match, right? D and C don't match. Now I got two possibilities here. Now I got two possibilities here. I can either consider, I can either consider to remove D from this thing, so that now I match A, B, C and AC, or or I can either remove C from here to match A, B, okay, A, B, C. I remove D from here, and I can remove C from here to match with this. Among these, whichever would give me the maximum, I would take it. Perhaps this gives me the maximum. It has A and C. This has only A. So this would give me the maximum of 2. All right. So this is what you'll be doing. One more simple recap. Let's say you have A, B, C, D, E. Let's say you have A, B, C, D, E and A, C, E. E and E matched. That means this gave you a subsequence 1. Now you need to check for these parts. D and C didn't match. D and C did not match. So either you choose to remove D from here and consider ABC. That means you can move a pointer. Let's say you're maintaining a pointer here initially. These two things matched. then you move pointer to here, D and C, they didn't match. So now you either choose to move this pointer ahead by doing this, or you can either choose to move this pointer ahead by moving it here. Fine. This is how things would work. And by the end of this, what would happen? You would get this thing, E and D matched, D and C didn't match. So let's say you have moved this pointer ahead, C and C matched. So let's say till here the longest common subsequence length is 2. Now you're left with A, B and A. Let's say the pointers are here. B and A didn't match. Move this pointer here. A and A matched. A and A matched. So the current length would be 3. And 3 is indeed the answer. Fine, this is how things would work. So let us make a function LCS.cpp and let's write the code recursively. Okay, first we'll be writing the recursive approach here. So the recursive approach would be string s, string t, and the two pointers. Sorry, the two pointers, which are the sizes itself. In recursion, we can do like bottom-up thing. So you can take the sizes itself as the pointers. So what are static variables, static parameters here? Static parameters are s and t, and uh, state variables are n and m. All right. Why are we doing this? I haven't made a dedicated DP video, but this is how you write state variables, because while writing the state logic, you need to compute the number of dimensions. And you can, if you are having a good clarity with the state variables and static parameters, you know how many dimensions it could ideally take. Fine. So you have a recursive function. What's the structure of recursion? Pruning, base case, and recursive calls. Fine. Let's go with recursive calls first. Then let's figure out. So divide and conquer works like recursion or divide and conquer. Both are the same things. So divide and conquer works like there's a huge problem. Then you break them into sub problems. Then you break them into further more sub problems, maybe like this, until you make them into some solvable problems. So these solvable problems, once we are uh, done with the recursion logic, at the end we'll be figuring out what are the solvable problems at which this whole recursion should terminate. Okay. So first thing, s of n minus 1 matches with t of m minus 1. Okay, because n and m are sizes, the indices, the respective corresponding indices would be n minus 1 and m minus 1. If they match, what I'll do, I'll add a plus 1 to my answer, because I found longest common subsequence of length 1, plus whatever the longest common subsequence I can find by removing that part. Let's say this is a b c d e, a c e, and till here I found length 1. Now I need to consider for these two strings. So I'll be doing it for recursion of s, t. Static parameters won't change. State variables are now n minus 1. You'll be considering the first n minus 1 characters, or the n minus 1th character, and m minus 1th character. Okay, you're removing the nth character and mth character. Fine. Now, once you're done with this, if these characters don't match, you got two choices. Either either you can move Either you can remove one character from S string like D and compare A, B, C and AC, or you can remove one character from T string. By removing C, you compare A, B, C, A, B, C, D and A. So which choice is best for you? How would you figure out? Just return the max, because, okay, we forgot to write return statements here. So return maximum of whichever gives you the maximum. Recursion of statics won't change. N minus 1 M. Either you can remove one character from S string, or you can either remove one character from T string. Whichever gives you the maximum is the best choice at that moment. And uh, now coming to the base case, when does this problem get completely decomposed? What do I mean completely decomposed? When can you say a divide and conquer problem is completely decomposed is one thing. If it uh, returns a case which is an exception. The second possibility when it's completely decomposed is it gives you one such problem which does not follow the recursion relation. Alright. So there are two cases when divide and conquer problem would give you the completely decomposed state. Let's talk about this thing. Let's talk about this thing. It gives you one such problem that does not follow the recursion relation. Okay. What does this mean? Let's take example of Fibonacci. Okay, Fibonacci. So if you observe Fibonacci of 0 is not equal to Fibonacci of minus 1 plus Fibonacci of minus 2. Fine. Fibonacci of 0 is not equal to Fibonacci of minus 1 and Fibonacci of minus 2 because they don't exist. They don't exist. They don't exist. Alright. And Fibonacci of 1 not equal to Fibonacci of 0 plus Fibonacci of minus 1 because Fibonacci of minus 1 doesn't exist. So here the recursion relation is broken. The recursion relation is broken. So you include them in your base case. If you are familiar with writing the Fibonacci logic, it's basically like this. You have this base case. If n is less than 2, return n. Alright, this is what happens. So this is where the recursion logic breaks. This case, the recursion logic breaks. So it gives you one such problem which doesn't follow the recursion relation. What's the second thing? What's the second thing? The same thing. The same thing would come under this case also. Returns a case which is an exception. All right. This Fibonacci of 0 is an exception because Fibonacci of minus 1 and Fibonacci of minus 2 doesn't exist at all. So for this thing, tell me one such case which is impossible. Tell me one such case which is impossible. So if n minus 1 is negative, that means n is 0. If n is 0, if n is 0, or if m is 0, okay. Why are we taking or? Why are we taking or? Logically, it's correct, but there's one more thing you need to be careful about. Sometimes only m doesn't change, but n changes. Sometimes only n doesn't change, but m changes. So it's basically like either m would change or n would change. So this is the way you figure out the cases where the recursion logic breaks, and these are the subproblems you can manually solve or forcefully solve. Okay. So in these cases, let's figure out what would happen. So if n is equal to 0 and there's a string left over, in this case, the longest common subsequence would be 0. So written 0. Fine. So this is the logic for longest common subsequence recursively. Recursively. So let's test it out. Let's do C out recursion of A, B, C, D, E and A, C, E. N would be 5, M would be 3. Let's create a problem. Expected output would be 3. Let's run this and it passed. Okay. Expected output and received output matched. That means we are doing it right. Now, how to get the intuition of DP here? The two pointer logic is clear, right? How does two pointer help in this one? Like you keep a pointer nth for the mth character, and move it by exploring all the possibilities. So the two pointer logic is clear. Now, when does the overlapping subproblem actually forms? Okay, when does it actually form? Let's take A, B, C, D, E, A, C, E. This part is done. Now you have two choices, which is matching A, B, C, D with A or matching A, B, C with AC. All right. So there are these things which is repeated again. Okay. So these are the overlapping subproblems for which you'll be solving the problem once again. So you're solving the same problem multiple times. So there's a scope to optimize this by using a dynamic programming solution. So how to apply DP for this? Very simple. Let's make a vector int. Okay, wait. What should be the dimension of the DP array which we'll be making? What would be the dimensions? Like, is it a 2D array or a 1D array or a 3D array, or uh, we don't even need an array, like it could be some variables. Okay. So the number of dimensions is always equal to the number of state variables n and m because they'll be dynamically changing. you'll be needing a 2D array because there are two state variables. So let's make vector int dp of size n and vector int m initially filled with -1 denoting we haven't visited a particular subproblem, and we'll be passing this as a argument everywhere. Okay, so fine, passed it as an argument. Now, what's the DP thing we'll be doing? Before actually starting the recursive calls, let's do a cache check. Let's do a simple cache check. If DP of let's say n and m is previously solved problem, not equal to -1 means the problem was previously visited. So if it's a previously solved problem or a previously visited problem, then return whatever the output of that particular problem was. Return dp of n comma m. So if I'm returning dp of n comma m, the size should be n plus 1 comma n plus 1, my bad. N plus 1, n plus 1. And before actually storing, before actually returning, store every return value. Okay, so now the dp solution should also work. Okay, did we miss the parameter somewhere? Yeah, we didn't pass here dp. Is there anywhere we missed? N was not declared in this scope. Okay, we haven't. Okay, fine. Let's take n equal to 5 and m equal to n equal to 5 and n equal to 3. Declaration issues, that's it. Simple. Okay. This is a syntax error. Return dp of n m equal to 0. Okay. So the same thing once again passed. Let me once again reiterate over dp solution. So what does DP principle say? DP principle say instead of computing one subproblem multiple times, store it somewhere so that you can use it whenever you need it again. Okay. So if n equal to 0, m equal to 0, before returning, you actually store it. You actually store it in a DP array. You actually store it in a DP array. And why do we need two states? Because there are two state variables. What does state variable mean? They uniquely define a recursion state. Because if I take only n, there could be multiple mappings of n with different values of m. So it would never give you a right answer. You cannot consider only n or only m. To uniquely identify a particular answer that you obtain from any previous subproblem, you would need two state variables compulsory. So before actually returning, just store it so that you can reuse it. So this applies for everything. Before returning, just store it somewhere so that you can reuse it. And if it's a previously computed state, just return it. If it was a previously computed one, just return it without computing it again. Okay, this is the part where you'll do computation. Skip the computation. If it's previously computed, just return it. That's what DP principles say. So after applying DP, we can further optimize it. Recursion takes stack space, so it's not optimal. Let's go with a tabulation solution. All right, let's go with a tabulation solution. A tabulation solution is much easier. It's just iterative DP. So let's make a, all right, let's copy the actual function from lead code. So let's remove all this. Let's retype it hash include bits standard C++ using namespace std, or else we don't need them actually. Let's do simple. Let's create a solution object. Cout sold or longest common subsequence. We'll be entering SMT. Let's edit the variable names because they are too big to type. Okay, fine. Now, what does the tabulation say? Tabulation basically says, instead of doing it this way, you have done it like A, B, C, D, E, A, B, C, sorry, what was it? A, C, E. You have done it this way, right? But this time what you will do is basically consider this part, then this part, then this part, then this part. So it's basically a bottom up thing. It's an iterative thing. Okay. Don't compute till n. Don't compute till n. Don't compute the whole thing. First, compute compute till some I, compute till some j, compute till some j, compute till some I. Then to this next increase the I and compute for this string, compute for this string. Next increase the I, compute for this string. So this is how the tabulation would work. So let's take the same dp vector int dp. The state variables won't change yet. So the size of the dp array would be n plus 1 and m plus 1. All right. So what was the base case? What was the base case if n equal to 0 or m equal to 0? Just written 0, right? So this was the base case. We'll be doing this for the dp array. Instead of base case, we'll be assigning the values to it. So for int I equal to 0, I less than n plus 1, I plus plus. So whenever m equal to 0, that means dp of I, m is 0. When m is 0, dp of I0 would be 0 and I less than m plus 1, I plus plus. dp of when n equal to 0 and m could be anything, m could be anything. In that case also it would be 0. So instead of writing this, how about making the whole dpr is 0, making the whole dpr is 0 and computing from here for int I equal to 1, I less than n plus 1, I plus plus, and for int j equal to 1, j less than m plus 1 and j plus plus. How about doing this? Because you have skipped I equal to 0 and j equal to 0 and assigned them to already 0, it won't change anything. And all we need to write is the same recursion logic for what we wrote for the whole thing. We just need to write the same thing for 0 to I, 0 to j. So how would this work? dp of ij, first thing, if s of I minus 1, because there we took s of n minus 1, equal to t of j minus 1, because there we took n minus 1. If both of them are equal, what you'll do? You'll do uh, dp of ij equal to dp of I minus 1, j minus 1 plus 1. Same recursion logic. And else, otherwise what you'll do? Otherwise you'll do dp of ij equal to maximum of dp of I minus 1 j and dp of I j minus 1. Fine. This is what you'll do. The same recursion logic. And at the end you'll return. What's your main problem? Solving it for string of size n, string of size n and string of size m. This would be your main thing. Let's remove this comment. All right. So let's give the strings because we are taking string inputs this time. A, B, C, D, and AC. This should print 3 and it passed. Okay. So this is how you write the DP solution for longest common subsequence, iterative DP1. So let's submit this. All right, so it works. Next, coming to the other problem, I guess lead code has some more problems. Longest palindromic subsequence. This can be done optimally by Manaker algorithm. Delete operation for 2 strings. Let's try out this one. Let's discuss Manaker algorithm some other day. So once again, you'll be given 2 strings. word 1, word 2, return the minimum number of steps to make word 1, word 2 same. In one step, you can exactly delete one character in either string. Okay. So uh, in one step, you can delete exactly one character in either string. So you need to make C to eat. Fine. How would you do this? Once again, the same idea. It's about matching. It's about matching. It's about two sequences. It's about trying out all possibilities. That means it's two pointer DP or LCS style DP. Okay. So one more thing you should be noticing that I have taken a random problem because lead code gave me a suggestion. I haven't solved it. I haven't messed up with it previously. So let's solve this. And solving a random problem, especially learning from solving a random problem, would develop great intuitions. Most of the YouTubers pick their own problem set and solve them, which is in one way destroys the intuition, natural intuition. So you don't know how the actual instructor thinks, what's his ideology, and you cannot learn it. So yeah, keeping all that aside, matching two sequences, trying out all possibilities. So it's two pointer DP. What you need to do, you need to take this C and eat. Let's say, let's say you matched something. You just need to count number of deletions, right? You just need to count number of deletions. So if two characters did not match, if two characters did not match, just like this, what you will do? You can either choose to delete this character or you can either choose to delete this character. That means when two characters don't match, you can either choose to delete one character from here, one character from here. Let's say I have deleted this T. So I'm left with C and EA. All right, fine. Once I'm left with C and EA, A and A matched. A and A matched. So I would not do anything, just continue. E and E matched, just continue. Empty string and S didn't match, remove S. So it took me one deletion and two deletions. So I just need to count this. Let's write recursive logic for this. Let's make a new file. Let's call it, what was the question? Delete operation for two strings. Let's call it some delete ops.cpp. Fine. So let's take a recursive function which takes two static parameters and two state variables. We would have a base case. We might have a pruning, and we would obviously have a recursive calls. Okay, fine. If s of n minus 1 is equal to t of m minus 1. In that case, what were we doing? We were just continuing. Till that part, it was fine. Just continue. What does continuing mean? Call the same recursion for next characters, n minus 1 and n minus 1. Okay. Then else. If they don't match, what am I doing? I should be doing, okay, if they don't match, I should be deleting. That means I would take one delete operation, and if they don't match, I would take one delete operation, and that delete operation, uh, I can either delete s of, sorry, st n minus 1 m, or I can either do recursion of st n m minus 1. That means I can delete either the character from the string s or character from the string t. How would I figure out which is the best for me? How would I figure out which is the best for me? Does the problem say anything about this? Return the minimum number of steps. Return the minimum number of steps. That means I need to minimize this. Otherwise, I can do, if I want to maximize it, I would make both of them empty strings. I would delete all characters from string S, all characters from string T. If they didn't mention anything, that would be the best. That's the greedy solution if the question was different. So I need to minimize this. That's very clear. And think of the base case now. Okay. So once again, the base case, if either of them is empty, if n equal to 0 or m equal to 0, in that case, return max of n comma m. Let me explain this. How did I come up with this? If let's say this is ABC and other thing is an empty string, to make this to this, you need to delete all these characters, right? You need to delete all these characters. So you would need three operations and vice versa. If this is a bigger string, to delete it, you would require that many. Okay. So return max of n comma m. Now let's run this, but we messed up with the parentheses. So let's do cout. The strings would be S was C, this was eat, 3, 3, and the output was supposed to be 2. Failed. Okay, we are not returning here. So let's add a return statement here. Yeah, passed. That means whatever the logic we have thought is right. Now let's apply memorization to this, or else whichever is the best. Let's go directly for tabulation. Let's don't waste time. Let's directly go for tabulation. So it's here. Coming to the tabulation. What are the state variables? State variables are n and m. So you would need a 2D array of size n plus 1 and n plus 1. Sorry, int n equal to, let's change the variables. I hate lead code for this. They keep giving longer variable names, nums and stuff. I'm habituated to write ARR. Okay, so let's figure this out. So if I equal to 0, you can either write two separate for loops here or you can write it inside this only. Anything is the same. Or j equal to 0. In that case, you will be doing dp of I j equal to max of I comma j. And if s of I minus 1 equal to t of j minus 1, dp of ij is equal to dp of I minus 1, j minus 1, else dp of ij equal to dp of I minus 1, sorry, 1 plus minimum of dp of I minus 1 j comma dp of I j minus 1. Fine. So that's it. And we need to be returning dp of n comma m, which is the main problem. So let's, before submitting it, let's check locally. Let's take a string s and t. So the input would be c and eat. Okay, got an error, a missing semicolon. Failed. What's wrong with this? Recursive version works, but this doesn't. Okay, I guess we need to compute this separately. However, I'm habituated to writing it that way only. I less than or equal to n, I plus plus, and dp of I0 equal to I. dp of 0I equal to I. Still it's the same. Okay, we forgot to change these. Yeah, passed. Okay, why was this an error? Why was the previous one giving a logical error? Because before you take dp of I minus 1, if I is let's say 1, the zeroth row must be pre-calculated, and if you are taking j minus 1, the previous jth row should be pre-calculated. So that was the problem, nothing else. So debugging, just random debugging. Accepted. Then let's submit. Same logic as LCS, right? Make 3 strings equal and minimum ASCII delete sum for 2 strings. Let's see the edit distance problem first because it's a more of classic problem, and once we are done with it, we'll be solving this. We won't be solving this because it's an easy problem. Fine. So given 2 strings word1 and word2, return the minimum number of operations required to convert word1 to word2. You have the following 3 operations permitted on a word. Minimum number of operations. Okay, minimum number of operations. You can either insert a character, you can either delete a character, or you can either replace a character. These are the 3 operations you can do, and you need to convert word1 to word2. So let's write simple recursion logic for this first. All right. So let's create a new file named edit distance.cpp. Okay, so this would be the last time I'll be telling you the visualization part, because in an actual contest, you should be able to visualize. Uh, yeah, you should be able to visualize, right? Because you don't have time to draw all this stuff. So what's the problem saying? You will be given 2 strings. What were the test cases? Horse and Ross. Let's write it down. You'll have horse, you'll have Ross. What are the operations you can do? You can either insert, delete, or you can either replace characters. So you can insert, delete, or replace characters. Fine. So let's say nth character, and nth character matched or doesn't match. Okay, let's go with the test case itself. Let's say nth and mth character doesn't match. If they don't match, what should you be doing? You can either move the pointer here. You can either move the pointer here and keep this pointer here only, which would mean delete operation, like you're deleting this and moving the pointer here. Otherwise, if they don't match, you can insert this character here. You can insert an S here. That means you are basically moving this pointer here. This thing has already matched. Hypothetically inserting S, okay, not actually modifying the strings, because modifying string itself is a headache. So inserting just means hypothetically inserting. You need not insert anything in the actual string, not inserting physically, just hypothetically inserting. That would mean you have inserted an S here, matched these two S's, and moved the pointer to here. Okay. So deletion means deleting this. Insertion means basically deleting this, because hypothetically you are inserting the same character here. That would mean this character is already matched. All right. So clear with insertion logic and deletion logic. What about replacing? What about replacing? Replacing would mean you have made this E into S so that both of them match. That means you should do this pointer to here, this pointer to here. You need to match both of them. Like replacing is moving both the pointers. Fine. So till here the logic is clear. Let's write the same structure: base case, pruning and base case, and recursive calls. So the pruning, there's no pruning. Let's go with the recursion first. So if both the characters match, nth character equal to mth character, if they match, you should go for moving both the pointers, right? If both of them match, like if it's this way, if it's something like ACD and BAD, these two characters match, that means you should go with these strings to find the minimum operations. Because for these characters, if they match, they would take 0 operations. Okay, you need to consider only these strings. That means you should move for, where is it? Yeah, let's close all these. Yeah, static stuff won't change. You should move for n-1 and m-1. Okay, once you return this thing, if they don't match, what you should be doing, you should be returning, you would take either one delete operation or replace operation or insert operation, and you should take whichever gives you the minimum. That's the best choice. If, let's say, deleting from string s, gives you the best, or it could be deleting from, sorry, inserting a character, that would mean you should move the pointer for the t string. Okay, you should move the pointer for the t string, because you will be inserting a character that already matches with whatever the character is at mth position. So you should be moving the m pointer. So n, m-1, or you can be replacing the character. That means both the characters are eliminated. So st, n-1 and m-1, whichever gives you the minimum. All right. Now think of the base case. Base case is once again same. The exception condition, or where the recursion logic breaks, m equal to 0. Now let's analyze the base case. Is this a problem we can solve? If it's an empty string, n equal to 0, and let's say there's another string abc here, to make this to this, how many operations it would take? It would take, let's say this size is m, it would take m insert operations. And if this is the case, abc, you need to convert abc to an empty string. This would take n delete operations. Fine, this would take n delete operations. If both are 0, it would take 0 operations. So that means it would take it would take maximum of n comma m operations. So let's test this out. Let's call cout recurrence of horse ross, length is 5, length is 3. Create a problem. Expected output is, what's the expected output? Should be 3. So the answer for this would be 3. Let's see if this works. And we got an error. Arguments, okay, n-1 and m. We forgot to put an m here. Fine. Run it again. Now what's the problem? Okay, so it's a syntax related bug. Okay, not a bug actually, error from my side. So whenever we are comparing three things, we should make it a tuple. Okay, we should make it a tuple. Fine, passed. So that's it. The recursion logic is clear. Writing DP is a piece of cake now, I hope. So let's take this. And we need to be making, there are two state variables, so two-dimensional array. This would be SNT. This would be of size n plus 1, n plus 1. I less than or equal to n and I plus plus. So dp of I0 equal to I, because obviously between I and 0 the maximum would always be I, right? If both of them are 0 the maximum would be 0, which is still I, so it doesn't matter. So in j equal to 0, j less than or equal to m, j plus plus, dp of 0j equal to j, wrong parentheses, I equal to 1, I less than or equal to n, I plus plus. Now what's the logic? If both the characters match, s of I minus 1 equal to t of j minus 1. If both of them match, dp of ij would be equal to, no need to add any moves, dp of I minus 1, j minus 1. Just remove those characters. They don't contribute to any moves, okay? And if they don't match, if s of I minus 1 and t of j minus 1 don't match, what should we do? Uh, we should be doing it like dp of ij equal to 1 plus whichever is the best choice between deleting one character from S or inserting one character to S, which would mean not considering the jth character of T, or dp of I minus 1, j minus 1, replacing the ith character with jth character so that both of them are matched. Now, what's our main problem? dp of n comma n. This is the main problem which we are solving. Now let's see if this works. String S, T, and let's make a solution object, solution sol. See out sol dot. What's the function name? It's min distance again. Fine. Min distance of st. So let's give it an input now. Horse and Ross. It should print output 3. Okay. Once again the tuple thing. Okay, yeah, I forgot. So we should make it a tuple. Yeah, and it passed. So I hope by solving these three problems, the algorithm intuition is clear. Okay, wait, didn't it get copied properly? Let's copy it again. Let's submit it. So it passes. We were about to do this problem, right? So we have two more problem suggestions here. Let's don't let this page go. Let's do that problem from here. Minimum ASCII delete sum. Okay, so given two strings S and T, S1 and S2, we will be taking it as S and T, however. Return the lowest ASCII sum of deleted characters to make two strings equal. So once again, it's the same. Instead of adding the number of moves, now we need to add the ASCII characters, which is another variation of the problem, I would say. So let's code this here itself. Let's change the variable names. Nothing new, that's why we'll be doing it very easily. So vector int dp n plus 1 vector int n plus 1. Let's declare n and m. Int m equal to t dot size, and let's forget the base case for now, or else let's write the base case. For int I equal to 0, I less than n, I plus plus, I less than or equal to n, I plus plus, and dp of I 0. What would dp of I 0 would be equal to? Let's think of it like let's say there's ABC, let's say there's this thing, and you can, what can you do? Can you do only delete operation, I guess? You can only do delete operation. Fine. You can only do delete operation from either of the strings. So to make this to this, I need to be deleting all the characters. I need to be deleting all the characters. And how can I get ASCII sum of all these characters? How can I get ASCII sum of all these characters? One way would be manually extracting the character and doing the ASCII sum. Is that feasible? Let's look at the constraints. Yeah, it's feasible. Constraints are only 1 to 1000, so it should be working. So dp of ij, let's take it 0. In this case, we'll be adding all the ASCII value sums for auto ampersand character in S. Okay, this means t is empty. T is empty. So what you'll be doing is dp of I0 plus equal to, let's typecast this to integer and int c. All right, int c. Or however, the array is itself an integer, so explicitly it would implicitly it would typecast, however. And for int j equal to 0, j less than or equal to m, j plus plus dp of 0j equal to initially 0, but let's compute it for auto ampersand c in s, dp of I0 plus equal to c. Now coming to the main loop. Uh, okay, wait. Okay, wait. This can be solved in a more elegant way, I would say. Let's solve it recursively first. I got an idea. What if we take the total sum of both these strings, like total ASCII sum of both these strings, and then while deleting, if we remove those things from the sum, it would work better, right? It would work better. So uh, let's try to solve it recursively. Let's try to solve it recursively first. Let's close this. Let's take another file, ascii.cpp. Okay, what if we take the total ASCII sum first? So the recursive function would take string s, string t, int n, int m, int a, which would be the ASCII sum of, or else let's take it as, and let's take it bs or at. Okay, so ASCII sum of a, ASCII sum of s, and ASCII sum of t. Let's take it this way. So what are the state variables here? State variables are like strings would not change, n and m would change, ASCII sum would change. Can we do it this way? So if n equal to 0 or m equal to 0, we just need to return max of ASCII sum of a, as, and at. ASCII sum of a and ASCII sum of t. We need to return the maximum. And if s of n minus 1 is equal to t of n minus 1, that means we need not delete anything. We need not delete anything. Keep it the same way. So it would call return the recursion of st, nm, and ASCII sum of s, ASCII sum of t would remain constant. If they don't match, what should you do? If they don't match, what should you do? Uh, if they don't match, return. You'll be deleting one character, right? You'll be deleting one character. and that one character could either be, we need not bother about that one character only. You can directly just return recurrence of st nm, sorry, n minus 1 m, and recursion of st n m minus 1, whichever gives you the minimum. And now let's talk about the ASCII sums. If you are removing one character from ASCII sum of from S, ASCII sum would reduce to ASCII sum minus S of that one character, which is n minus 1 character. And ASCII sum of T won't change. ASCII sum of S won't change, and ASCII sum of T would become minus ASCII sum of m minus 1. This is what would happen, right? Now, how can you actually know the moves with this? Okay, I guess this thing is wrong. Better we write it as AS plus AT. Let me explain this recursion thing to you. Wait, Control B and how to do that? Is that Control Alt? No. Okay, whatever. Forgot how to split tabs in VS Code. There was some shortcut key. Fine. So let's say one of the string is 0. Let's say one of the string is 0. A, B, C and empty string. In that case, ASCII value of A plus ASCII value of B plus ASCII value of C would be the sum. Let's say ASCII value of A is A itself, B is B itself, C is C itself. So A plus B plus C should be the answer. Alright. So this is the base case. For this string, the ASCII value sum would be 0. Right? The ASCII value sum would be 0. Now coming to the recursion logic, if let's say you have something like C and eat, what are we doing? If these two things doesn't match, we would need to delete either one of them. Okay, we need to either delete A or we need to either delete T. Let's say I delete T. What would happen? So T's ASCII value should get added to it, but it's getting subtracted from the total sum. So it is something like ASCII value of S minus, so it's ASCII value of, sorry, T, right? It's E plus A plus T minus T. All right. So at the end, we are deleting one character from here. And EA won't get deleted. S would get deleted. So S plus E plus A minus S. These two things are getting deleted. And the answer should be T plus S. So solve it in such a way that the answer would be T plus S. How can we solve it in such a way? We can do AS, original AS minus the AS which we are computing, and let's say OGAT minus OG ASCII sum of T minus the AS which we are up to. If we do this, we'll get the answer. So there would be two more static stuff, which is int OGA, OGS and int OGT. All right. So if one of them is 0, we need to be returning, if one of them becomes 0, we need to be returning OGS minus AS, OGT minus AT. All right, and OGS and OGT would never change. OGS, OGT would never change. Let's take it here also. OGS and OGT. Is that how it's supposed to be? No, wait, we can write it better, I guess. Let's rewrite it. This is a bad idea actually. Let's go with the previous approach only, string s. So this is very natural problem solving session. I'll be making mistakes too. So if n equal to 0 or m equal to 0, then you need to return max of n. What was actually, this seems right. The previous one seems right. Hmm. Okay, let's try running this once. So let's try running this once. We'll be doing C out recursion of C 8, n would be 3, m would be 3, OGS would be 3, OGT would also be 3. All right. So we might be wrong on this actually. What's the answer here? Answer is 231. I'm feeling we are wrong logically. Okay, syntactically also wrong. Wow. Missing parameter somewhere. Okay, wait. Here we are missing OGS and OGT. And we also missed ASCII sum, complete ASCII sum of these things. So n and m are fine. ASCII sum should be computed for these two strings. Uh, let's compute it. Int 80 equal to 0. Int as equal to 0. Okay, string t equal to 0. Sorry, string t equal to 8 and 80 plus equal to c. Let's repeat the same thing for t also. This should be as 80 as 80. Did we miss a written statement somewhere? You're printing it right. Okay, wait, let's think of this problem once again from scratch. Sorry for this. So you have an int recursion. You take two strings, string s, string t, int n, int n. That's it. This should be the state. Let's say uh, if n equal to 0 or m equal to 0, it would take as much as ASCII sum of the maximum of n comma m. So let's leave it for now. Let's write the recursion logic first. So if s of n minus 1 matches with t of m minus 1, just do recursion of s t n minus 1 n minus 1. Not gonna change anything. Otherwise you'll be adding, else you'll be adding return. Here also return. Here you'll be adding return s of n minus 1 whichever gives you the minimum, s of n minus 1 plus recursion of s t. That means you have removed one character from s, m, and s of m minus 1 plus recursion of, sorry, this should be t of m minus 1 plus recursion of s t n m minus 1. So the recursion thing is clear. Now let's think of the base case. When this is equal to 0, what you need to be doing is uh, when one of them is 0. If one of them is 0, that's a single if statement. In that case, you need to be mm, if let's say n is not 0. If both are 0, in that case return 0. Otherwise, if m is not 0, or let's say both are 0. If both are 0, then just return 0. If n is not 0, just iterate and in sum equal to 0, go till n and just do sum plus equal to s of I. Otherwise, or let's just declare this sum variable outside everything. Yeah, just to return sum here for int I equal to 0, I less than n, I plus plus sum plus equal to t of I. Alright, sum plus equal to t of I. We'll be returning the sum. So here we have reduced the complexity by doing this computation only once. This should be working, I guess. So let's do cout recurrence of c eat n equal to 3, m equal to 3. We missed something. It says we missed expected this before that. Expected semicolon. If n greater than 0, if m greater than 0. Did we miss any semicolon somewhere? Okay, wait. It should be else if, right? That's the problem. Still there's no output. Yeah, passed. So let's apply the DP for the same. Okay, that was a tricky question because there were several other thoughts in my mind. So let's solve this question using DP now. Once the recursion logic is figured out, DP is quite easy. All right, so hmm. So here, coming to this part, when I equal to 0, sorry, when j is 0, that means m is 0. Initially this will be 0 and we'll be doing for int I equal to 0, I less than. So in this case, n is non-zero. So that means string s is not empty. So to this we'll be adding dp of I0 plus equal to s of I, and j less than or equal to n j plus plus dp of 0 j. Actually we don't need it here, keep it 0 here itself, plus equal to t of j for int j equal to 0. Okay, wait, this is how. For int j equal to 0 j less than m j plus plus dp of 0 j plus equal to t of j. Fine, this seems right. Yeah, same thing which we are doing in this base case, we are doing the same thing here also. So now let's write the main transition loop. So what was the transition? If s of I minus 1 equal to t of j minus 1, then dp of ij is same as dp of, after removing that ith and jth character, would still give the same answer. And if they don't match, in that case dp of ij is equal to minimum of s of I minus 1 plus dp of one character removed from s and s of j minus 1, sorry, t of j minus 1 and one character removed from t. And the main problem will be, we need to be solving is dp of n comma m. Let's see if this thing works. So let's run this. Okay, n and m are not declared. N equal to s dot size, m equal to t dot size. Wrong answer. So let's go back to VS Code. Okay, dp of 0 0 would always be 0, right? dp of 0. So we can start this from 1. Now let's test this locally. Solution sol dot minimum delete sum. Minimum delete sum of strings we'll be passing is, let's take string s t cns t. Minimum delete sum of s comma t, and we'll be doing this c out. So the strings were c and eat. Okay, we are getting an output 213. I equal to 1 means, okay, so it's this way. When I equal to 1, that means I is greater than 0. For int I equal to 0, I less than n, I plus plus. dp of I0, which denotes the sum, plus equal to s of I. And dp of j less than m, j plus plus. How to solve this? We wrote the same thing as we wrote in recursion. So, hmm, are we doing this thing in a wrong way? S of I minus 1 plus dp of I minus 1 j, tj minus 1. Let's debug this. dp of, let's do C error dp of. So okay, this is showing something different. We should have taken it as j because both the loops are same variables. So, mhm. We are somewhere getting lost at these cases. When both are 0, this is clear that dp of 0, 0 would be 0. Let's take a variable sum. Let's take exactly this code and let's call this capital M. dp of capital N 0 would be equal to sum. And let's take once again sum equal to 0. And now let's copy this thing. dp of 0 j would be equal to sum. Now let's try running this. What happens? Still prints the same. We are good with the recursion logic. Mm, okay, got it. This should be less than n. See, we will be computing it for the value of n's, right? So it should be reflecting upon this loop. It's a very ugly mistake, I would say. Yeah. So that was all about it. So let's submit this. Should get accepted. Yeah, done. Yeah. So that was it. Number of ways to form a target string. We saw a few more questions here, right? Let's try solving this. Uncross lines. Okay, so this is the same algorithm but applied on integers. So you are given two sequences, maybe. And this is the same algorithm. I haven't read the question yet. You are given two integer arrays, nums1 and nums2. Write the integers of nums1 and nums2 in the order they are given on two separate horizontal lines. We may draw connecting lines and a straight line connecting two numbers, nums of I, first sequence and second sequence number, such that nums of I and nums of j are equal, and the line we draw doesn't intersect any other connecting non-horizontal line. So how to do this? Okay, let's try solving it. So you have numbers like 142, 124, 142 and 124. 2 and 4 clearly doesn't match. So you got two choices, either you delete 2 or either you delete 4. So let's say I chose to delete, let's say I chose to delete 2 first. What would happen? 1 4 would be left, 1 2 4 would be left. Now 4 4 is matching, 4 4 is matching. That means you can draw one straight line. Now you can continue with this sequence. 1 2 is not matching. I got two choices, either I can delete 1 or either I can delete 2. I chose to delete 2. So 1 1 is matching. So I'll draw one more line. So that's this way. Can I guarantee that lines won't cross? Yes, because I can guarantee, because I am going in only one direction. If I go in some multiple directions, the lines may cross. But since I'm going in a single direction and checking one by one, I don't think lines may get crossed. So let's make a new file, lines.cpp. So this would be the last question for today's session. Uh, so let's copy this. Let's directly write the DP solution for this. So int n equal to nums1 dot size, int m equal to nums2 dot size, and what if one of them is empty? What if one of them is empty? Let's say you have 124 and 142. Sorry, 124 and empty one. There's nothing here. In that case, how many lines can you draw? You can draw 0 lines. If one of them is empty, there are no lines possible at all. So for int I equal to 0, I less than or equal to n, I plus plus, dp of I 0 is equal to 0. For int j equal to 0, j less than or equal to n, j plus plus, dp of 0 j is equal to 0. Fine. If one of them is 0, you cannot draw any lines. And for int I equal to 1, I less than or equal to n, I plus plus. For int j equal to 1, j less than or equal to m, j plus plus. If s of I minus 1 matches with t of j minus 1, okay, we changed it. Let's take it s and t only. Got habituated to it. Okay, s of I minus 1 is equal to t of j minus 1. dp of ij equal to dp of I minus 1 j minus 1. Alright, dp of ij equal to dp of I minus 1 j minus 1. Just eliminate both the characters and just move on. Okay, and if they are not equal, is the question anything about minimization or something like that? Maximum number of connecting lines we can draw in this way. Maximum number of connecting lines. Okay, wait. If if it's a match, then we can add 1 plus the previous ones. Okay, and if it's not a match, you need to be doing dp of ij equal to max of dp of I minus 1 j comma dp of I j minus 1. And the main problem you'll be solving is dp of nm. Let's test it directly in the code. Copied it and pasted it. Yeah, it got accepted. Let's submit it. Done. So that was the algorithm for today. I hope the session was very clear. Stay tuned for more algorithms and more interesting sessions. So thank you everyone.